This video is about interacting with the environment, with command line arguments, environment variables, processes, exit codes, and a bit with the file system. Let's see what we have. We begin with command line arguments. In the std.env module, there's a function called args, which gives you an iterator on the command line arguments. If you call the collect method, which we have already seen, you can store things into a vector of strings, and these are your command line arguments. The first one with index 0 is the name of the program, of the executable, and then come the other command line arguments, as usual. There's a variant with the so-called OS string. An OS string is not known to be UTF-8, because after all, an operating string system file name can have different characters in some operating systems. And you get it with the args OS variable. So let's quickly see what an OS string is. Well, it is a wrapper around whatever is valid in the current operating system. Similarly, you can access the environment variables. If you ask for vars, you get an iterator on the key value pairs for the environment variables, here with strings and here with OS strings. So let me see what this does. Yeah, so that's lots of environment variables set, but the arguments are here, just the name of the command I execute. And if I do ABC here, then I see here ABC in the vector, and the environment will be a map, hash map. Next is the current working directory and file paths. If you use the current dir function, which obviously can report error, but if you get a proper result, then you get a type pathBuf. PathBuf is a type where you have the components of the path in a list, basically. Here you can iterate over the components of the path, so that immediately cuts the path into its pieces. You can pop the latest in the last component of the path, and you can push something to go one directory level down. So that's your pathBuf variable. If you want to take the environment variable path, then there is a convenient function split paths, which also gives you an iterator. And again, you have here pathBufs for the different paths, and you can work with them as expected. Now, you can also ask for the current executable, you can ask for a temporary directory, and this pwd as a pathBuf, you can ask for it to be as path, which goes to a path, and you can convert this to a string, which can obviously fail because it might not be valid UTF-8. So let's see this in action. Yes, we have the current working directory, we have it cut into its pieces. We go one level up by popping, and we can go one level down by pushing. Here we have the path variable nicely split into its components. Each of them are pathBufs. And we find the current executable with an absolute path. We have the temporary directory, and here again another path. There are also functions to modify directories. Here I start with the current directory, and then I get a dir builder object. I tell it to be recursive, and I create in one go in the current directory 3 directory hierarchies A, B, C. Obviously it can fail, so I get an error result, which I unwrap here. Now, if I push to the current working directory, a directory, that is like entering a directory, and I can use the readdir function on a pathBuf to read the directory contents. Now, dir is now a readdir type, and if I iterate over it, I get a dir entry, obviously wrapped into a result. And if I unwrap it, I have a dir entry. And in this dir entry, I can look at various interesting things. I can ask for the path. I can ask for metadata. And so therefore, I can derive interesting information about these directories. So let me run this. Here, the dir entry shows you the path. And then metadata, where you have the file type, whether it's a directory or not, you have permissions, modification times, access times, and so on. So that's exactly what the stat command can usually do for you under Linux. Finally, let me show you about the std process module. The one function I want to show you here is the exit function, which allows you to leave the program with the given exit code. So if I give as first argument yes, it will use exit code 0, and otherwise it will use exit code 17. Indeed, I get 17, and if I run with first argument yes, I get 0. This was it for this video. I've shown you a little bit of a guided tour around the modules in the std.env and std.process. Just look there for more and follow the links in the accompanying webpage. You can discover the rest of the functionality. I hope you enjoyed the video and I see you in the next one.